Okay, this video is to show you how to read and interpret a solubility curve. For the purposes of this video, we are going to focus on the sodium nitrate line, which is right here. I'm highlighting in green. Okay, so that's the one we're going to use in our examples. For right now, we're going to just ignore the rest of them. Okay, so just so you guys know, we have our axes. The x-axis is temperature. Okay, it's going to increase as we go left to right, and then the solubility is going to increase as we go up. The unit for solubility is grams for every 100 grams of water. So in this video, I'm going to go over all the different types of problems that you're going to do to prepare you for the test, as well as just kind of get a basic understanding of what solubility means, and specifically the term saturation. Okay. Mainly when we're referring to saturation, we're talking about the amount of solute that a solvent can properly or at least adequately dissolve. There is a point at which a solvent will no longer dissolve a solute, and that is what we mainly refer to as the saturation point, or the amount of solute in which the maximum amount of solute a solvent can dissolve. So, like I said, we're going to focus on sodium nitrate, which is going to be this guy right here. Okay, we're mainly focusing on this line. Now, there's a couple different problems that we're going to do. The very first one we're going to do is, how do you identify if a solution is soluble, or not soluble, but saturated, unsaturated, or what we call supersaturated? So, anything that is below this line, okay, at any point of the line, we would call that unsaturated. Okay, anything that is above the line, okay, we would call it super saturated. And lastly, anything that is on the line, right on it, okay, is saturated. All right, now I do have some space over here in black, and hopefully that shows when we do the problems. But one of the very first types of problems that you're going to have is this solution saturated, unsaturated, or supersaturated? So let's go ahead and take a look at, again, sodium nitrate, and let's say I had 80 grams of sodium nitrate dissolved in 100 grams of water at 70 degrees Celsius, or let's go 30 degrees Celsius. Well, at 30 degrees Celsius, which is right here, I'm going to look at 80 grams, which is right here, and this is where my dot is, right there. So that's describing my solution. I have 80 grams of sodium nitrate at 30 degrees Celsius. What type of solution is it? And as you can tell, if my solubility, or my saturation point at 30 degrees Celsius is right here, that is below that line, therefore it would be unsaturated. Okay. Another example, if I had 30 degrees again, but I had 120 grams of sodium nitrate, that means I would be right here. And if I'm right there, that's above the line, I would say that would be a supersaturated solution. And of course, if I said at 30 degrees Celsius I have 95 grams of sodium nitrate at 100 grams of water, that would be right on the line, and that would be a saturated solution. Now, the next type of problem that I would ask you about is, what is the solubility of a certain salt at a certain temperature? Again, we're going to focus on sodium nitrate. So if I asked you, what is the solubility of sodium nitrate at 60 degrees Celsius? So I would look right here at 60 degrees Celsius, go all the way up. At 60 degrees Celsius, I'm right there on that portion of the line. So we'll go ahead and write over here in black to see how this looks like. Okay, so let's go ahead and go over here. Now, if I have, if we look over, Okay, that's roughly about 121, 122. So the solubility of sodium nitrate at 60 degrees Celsius is 122 grams per 100 grams of water. This is my entire answer. Okay, I wouldn't just say 122 grams, I would say 122 grams per 100 grams of water. Okay, I cannot have just the mass. Now, if I was to ask you, what is the, how much sodium nitrate can I hold, or can a saturated solution hold at 60 degrees Celsius? Okay, so if I asked how much mass, or how much, then my answer would be just 122 grams. Okay, but if I ask for solubility, so solubility, I can spell today. Well, you guys know me, can I spell any day? If I'm asking for solubility, I need this unit. But if I ask for mass or just how much, then I can just use a mass unit. Okay? So just to kind of know what that question is again, if I say, what is the solubility of sodium nitrate at 60 degrees Celsius? It would be 122 grams per 100 grams of water. But if I said, how much sodium nitrate can a saturated solution hold at 60 degrees Celsius? Then that would be 122 grams. Okay, the next type of problem is going to be having to do with different types of mass, specifically if I change my temperature. Okay, as I'm sure you guys have realized, for a majority of these substances that you can see on this graph, but of course you've been ignoring all those other lines except the sodium nitrate line. Sodium nitrate, as the temperature increases, the solubility increases. And what you'll find is that's true for a lot of the ionic compounds that you see right here. There, of course, are some exceptions, but as you can tell, sodium chloride, okay, potassium chloride, ammonium nitrate, or sorry, ammonium chloride, ammonium nitrate, or sorry, potassium nitrate, and potassium iodide, and sodium nitrate, potassium chlorate, they will all increase as temperature goes up. Things like ammonia and other gases, they will decrease as the temperature goes up. Okay, this cerium sulfate will actually, even though it is a solid, it will increase as or decrease as the temperature goes up. But you can tell it levels off. But again, the main thing that we're dealing with here is going to be the sodium nitrate. So let's get back on point. All right, a type of question that I would ask would be how, if I had an unsaturated solution of sodium nitrate at 80 degrees Celsius. So I am, let's say I had 100 grams. Had 100 grams of sodium nitrate and 100 grams of water at 80 degrees Celsius. That would put me right here. The type of question I would ask would be, how much more solute, sodium nitrate, can I add to that solution to make it saturated? And all I would do is, at that temperature, 80 degrees, I would travel all the way up until I come across the saturation point at 80 degrees Celsius. In this case, would be about 142. So 142 grams per 100 grams of water. So that's the solubility at 80 degrees Celsius. And so what I would do is I would simply find the difference between those 2 points. So I would take 142 and I would subtract 100, and that would give me 42 grams, which means I could add 42 more grams to that solution to make it saturated, meaning that solution can hold 42 more grams of that solid. Okay? Now, just like if temperature increases, we can see an increase in solubility. If temperature decreases, we'll see a decrease. So let's go ahead and work with that same amount, or that same solution. So I have a saturated solution at 80 degrees Celsius. Now let's say I cooled down the solution. I cooled it down 40 degrees to reach 40. So now my temperature change has gone from 80 to 40, and my solubility, or my saturation point, is now right about here, right underneath the label. Okay, so now I'm right about here, which is roughly 105. If Now, obviously, I'm not going to be looking at how much solute can I add. Now that I'm losing some of my ability to dissolve, my solubility is decreasing, I want to find out how much salt is going to come out of solution. Okay, how much is going to precipitate out. Okay, so I have 142 minus 105, and that'll get me what, 37 grams. Which means if I was to cool down this saturated solution right here from 80 degrees to 40 degrees, I would expect 37 grams of sodium nitrate to precipitate out of the solution. Okay, so if I increase the temperature, I should have, I can calculate how much salt I can add. And if I decrease the temperature, I can find out how much salt is going to come out of the solution. Okay? Okay, the last types of problems that we're going to do is looking at situations where, if you look over here on the y-axis, okay, this is per 100 grams of water, but some of the problems that you're going to have may not have 100 grams of water. They may have 27 grams of water or 233 grams of water. So obviously, if I increase the amount of water, then I'm going to increase the solubility because I have more solvent. And if I decrease the amount of solvent, then I'm going to have a decreased solubility. So we'll do a couple examples, both with an increase in the amount of the solvent and then, of course, with a decrease in the amount of solvent. So looking over here, if I had a saturated solution at, let's go 50 degrees Celsius, which means I'm right here. Okay, so that's about what, 104, about 114. Okay, about 114 grams per 100 grams of water. So my question is, what if I had 236 grams of water? How much salt would I need to make a saturated solution? Okay, so 236 grams of water. That's how much I have. Okay, but this graph doesn't show me 100 grams. It doesn't show me 236 grams. It tells me 100 grams. So what I'll use is I will use a proportion. So if I want to find out what the saturated, how much solute I can add to a solution to make it saturated, if I have 236 grams of water, I can use the 114 grams of water per 100 grams, okay, or 114 grams of solute per 100 grams of water, and I can just make a proportion, 236 grams. So remember, these are both H2O, and these are both of the solute. Okay, so I'm just going to solve for x. So when I solve for x, I cross multiply, I end up with 100x equals 114 times 236, which means I have 100x equals 35,636. I divide that by 100 on both sides. X is going to equal 356. And then I'm going to, for right now, when it comes to solubility curves, you may ignore the rules of significant figures and just round to the ones place. So this was 356.36. Just go ahead and leave it as 356 grams. Which, of course, this means in 236 grams of water, I can dissolve up to 356 grams of the solute to make a saturated solution. And I could do this exact same problem if I had less than 100 grams of water. Let's say I had 12 grams of water. So I'll go ahead and use green so that looks like shows up a little better. So I go 100x equals 1368. Divide that by 100, and my x equals 13.68, which would be x equals 14 grams. Don't forget your units. Okay, so 14 grams would make a saturated solution if I had 12 grams of water because it is in proportion to what is present on my graph. All right. Now, of course, I can do a lot of different problems. If I really wanted to, I could solve for, um, you know, how much water would I need to dissolve let's say if I had um, 13 grams of the solute, how much water would it take to dissolve it? I can do both ways, but it's going to be the same type of problem where I will cross multiply and then solve for x and divide and do all that kind of stuff. So that's pretty much how to read and interpret your solubility curve. If you guys have any questions, make sure you ask in class.